Um, Thank you for the invitation. I'm very happy to be here in Prague, in your very beautiful historical city. I've never visited this city before. It's a great opportunity. Um, MDH is not a very old office. We established the office in 2010. We are with 3 partners and 6 to 8 employees. The project came into the office in quite an unusual way through a competition win. What wasn't so very usual about the competition was that there was young officers invited, officers with less than 8 years of experience, together with a more established firm. So for this competition, we collaborated with an older office with a one-man office, Arne Henriksen, and we were fortunate enough to win it. And that was in 2013. This ambition for the student organization in Trondheim to invite young officers was a clear signal to us that they really wanted to do something else and something new. The project is called Moholt 50/50 because it represents a milestone for the student village. The student village, which you can here see with the red marking around, it was built between the 1960s and 1970s. So the competition was organized when the Moholt student village turned 50 years, and it sought for visions for 50 years ahead. And that they wanted to have a vision for 50 years ahead was also promising, because they own these buildings and they manage these buildings. So they wanted to have something that was manageable and sustainable for 50 years ahead in time. So it was a quality ambition, a little bit out of the ordinary for housing. Many times when you build housing to sell. And when you sell it, you're not so interested in the sustainability or the manageability for further in time. You just want to sell it quickly and easy. But so the student organization were interested in solutions where you could have ecological and ecological solutions for a long-term perspective, with maybe a little bit more expensive investment, but which would pay back in the course of the coming years. Student accommodation, this is the existing buildings. Student accommodation often plumb the depths of mediocrity, like hutches stacked up in the simplest, cheapest way, without any support programs left to themselves in a kind of a anonymous place. And in many ways, our project is a reaction to this, not only from us, but also from the student organization. In the existing village, you can see it on your left, the gravity point of the student village was the northeast corner, because there was a grocery store there. So the whole dynamic of the village was in the corner, and there was a big parking lot in asphalt on the middle of this area. So we chose that area for intervention, and we wanted to connect all the small paths and roads which are now already existing, and also connect to the outer surroundings, to the neighborhood areas, so that we could erase this invisible border that many times exists around kind of mono-programmatic spaces like a student village, to invite people from the surrounding areas, and also to make this. Here's a big road, and there's the collective transport. So all these houses would have an easier access to the collective transport through the village. Also encourages collective transport. So the street, the meandering street, or almost like a river, which would then, which when split up to smaller paths, became the sort of organizing element for the whole project. The landscape plan was very important, and the whole this Moholt Allmenningen, as it's called, or Moholt Commons, it consists of play spaces and benches and planting and simply places where people can meet. Here you see an early plan with lots of things happening. It doesn't exactly have the same configuration today. The configuration up in the corner, that's the configuration we have today, and this was with another sort of kindergarten at the time. This is how it looks today, and the large part of the project is really the student towers. There are 5 student towers, and but there's also a large kindergarten to the project, which you can see a little bit of in the corner. The student towers in blue, and the kindergarten of 170 kids, so it's a little bit more than 2,000 square meters, also in cross-laminated timber. And the red marked building in the middle is a local library that is under detailing process at the moment, and will hopefully start construction at the end of this year. Together, they are actually the biggest CLT project in Europe at the moment. I'm sure someone will make a bigger project soon, but for the time being. Here you see this is the student towers, and then you see a picture of the kindergarten and the rendering of the coming library. The library is a local library, but with a big profiling towards students. So we will have study spaces for students together with normal library. So here you see the existing student village with the towers. The whole master plan from the 60s and 70s is really a representative of sort of late modernism ideals, with sort of similar cubes placed freely in a landscape among lots of greenery. And but in present day opinion, it's maybe a little bit uninspiring as a landscape, and it's maybe lost in the time when it was built. So we proposed tower-like constructions to mark this centrality, and also to propose a new mark and identity for the student village. The student villages, the student towers, have a Y-shaped form, and this is beneficial for a number of reasons. The large volumes are broken up into smaller parts, and the wings of the building hence meet the surrounding volumes in a better way with similar dimensions. Even though they're much higher, they're still the same dimension in plan. By breaking up the volume, you also create a more slender and elegant volume by adding more facets to it. The Y plan is an efficient organizer of placing the rooms in the wings, and this creates naturally a central communal space in the middle. Every floor is organized into a collective. They all look similar, except the first floors, and I'll come to that. So you have individual student units who have bathrooms, and then they share a kitchen and a living room space, and an entrance wardrobe, so they can leave all their shoes and clothes in here, and then this is a guest toilet for guests, which is kind of a handicap dimension. One of the cells is dimensioned for universally for universal use for handicapped for different reasons. So it is actually a very, very simple plan. Here you see a picture from the common room, and this is what the doors to the individual student units. This is what it looks like, can look like when you come in to a student unit. This is taken just before Christmas, so it's Christmas decorated. The ground floors of the towers offer commercial spaces, spaces that activate the Moholt Commons, and spaces for students. And this was something the student organization wanted, but it was also a demand from the city, because if you build higher towers in Trondheim, it gives a sort of signal, and that you have to sort of balance this signal up with that you actually offer something public. It's a policy they have in the city of Trondheim. So here in the blue tower, the blue basement ground floor, there's a health center for students and for normal people, and the yellow one is a training center. The green one is both a wash and go unit. It functions as a washing place for clothes for the entire student village. So it is a natural meeting spot for students. There's also a little a commercial space here, which is now used by a hairdresser. And this space is a grocery store, and this is an activity room, which hasn't got a tenant yet. And then this is the library. In the competition, we proposed, we knew that student housing is not something that you have to do cheaply. So we proposed a standard steel and concrete structure. But the project had very ambitious energy goals, and they wanted us to look into if it was possible to build the towers in CLT elements, cross-laminated timber constructions, and the towers with relatively short spans, and also the form of them that gave a kind of a statical, was beneficial in a static way actually, without any changes. So the client completely fell in love with this, the idea of building massive wood, as they say in Norway, they call it massive wood constructions. But there was a challenge, because at this point, massive wood buildings in this scale were not built very much in Norway. So in order to get a price from a contractor and entrepreneur, which was competitive to standard building methods, they had a very good idea. They did something extremely smart. They asked a consultancy firm to educate 4 different contractor firms, entrepreneurs, in how to price these sort of constructions, in order to avoid this kind of extra, we are a little bit unsure what it's going to cost, so we just add some extra price to it factor. And the goal was to get a competitive price to normal steel and concrete construction, and it worked because they gave prices on both of them, and in the end they went for the wooden CLT construction. For Norwegian standards, it had very ambitious energy profile. It might be that the energy ambitions in Austria or in Germany are more ambitious, but to meet these environmental profile, the choice of CLT in all load-bearing structures was important, and they also wanted to use a passive house energy profile, and they made a private heating plant, which then consists of 23 geothermal wells and heat recovery from ventilation air, and also heat recovery from wastewater, and solar thermal collectors. And these together work as a sort of like local heating plant. And the energy that they produce is bigger than they need for the towers, so it's also heating up the domestic water for the existing towers. Not towers, but the small cubic houses. The project reaches the objectives of at least 50% in CO2 emissions compared to a reference standard Norwegian tech regulation building. The use of CLT reduced the CO2 production in the building materials by 57% in comparison to traditional construction methods. And the CO2 emissions associated with energy use is reduced by approximately 70%. The 5 towers are 9 floors high and 28 meters. This one is actually 10 floors high because the basement is kind of half a basement and half a floor. But this is also usually when you build towers in Norway, you are only allowed to within certain fire rules to build 8 floors. And this is not because it's a wood building. This is because it has to do with fire escapes. So then you can only have like 1 staircase if you have 8 floors. If you go over that, you need also a fire escapes there for the fire brigade. But we managed to add an extra floor to this because Trondheim is one of the largest cities in Norway. It's the 3rd largest city, and they have very advanced equipment in the fire brigade. They have a big fire truck with a long fire ladder. So we could add 1 extra floor to the building because they could come up this high. All the basement and the 1st floor is constructed in cast concrete, and the rest of the floors are made in wooden structure. In the kindergarten, everything except the foundations is wooden construction, also the 1st floor, and it will be also in the library. Everything will be in CLT. So all the staircases and elevator cores are also in wood. Here you see the kindergarten together with one of the towers, and this is you can see the 5th tower is behind here, and then the placement of the future library. Here you see in one of the towers you see the moment where you go from concrete to massive wood and how they're kind of joined together, and this is further up in the building where you only have massive wood. And these big steel plates are stabilizers which you find in the lowest floor, but not in the highest floor anymore. The other lecturers have been in on this topic, and it's the precision and the montage speed is absolutely fabulous. It's they could build 2 floors in a week. So the construction the raw construction of the 3 first towers out of 5 was done in 12 weeks, 3 months. That's extremely fast. And you also get a very clean and a dry environment, so the builders are extremely happy to work inside here. There's no moisture and there's no dust, so it's also health beneficial for the people who work there. Here you can see that in the left image that the bathroom pods are arriving with a crane. They were built in Finland and then they were shipped to Norway and built on the site. It's a bathroom prefabricator who usually makes bathrooms to large ships and ferries. So these are made in Finland and they came to the building site. The precision of the wood, as I thought, is really, really great. That gives us architect a fantastic room to work with details, and we don't have to work with tolerance of 1 to 2 centimeters. Sometimes if the concrete work is done, concrete element work is really poor. Here it is really down to millimeters. The only let's say, unevenness that was created in these constructions was, of course, the first floor, which is, I mean, it's cast concrete, so it's better than elements, but still there was some small unevennesses, but nothing that couldn't be absorbed by the detailing. Our approach to building with CLT was to take advantage of the finished surface of the CLT element, to be able to expose it as much as possible in the interiors. Because wood has the capacity to withstand dents and scratches in a much better way, and it ages in a much worthy way than plasterboards and other plate materials. Here you see the structure of the CLT structure to your left, and to the right you see the sort of the ready built with the sort of some insulations and some plasterboards that we had to put in order to confine with acoustic and fire regulations. I will come back to that. The idea, the whole concept behind the detailing was to convey as much as possible of the technical and aesthetical qualities of the system, the sort of building system, modular building system that the CLT really is, and to make this a sort of the detailing philosophy. So sometimes we have even exaggerated. Like here, we have a recess in the deck element to kind of emphasize that it's a sort of a construction set, almost like a Lego set. We also there's also always this kind of a backbone reflex of entrepreneurs to put kind of finishings around all doors and windows in order to be able to not be so precise as you would want them to be. So we had many rounds of it probably doesn't seem like much, but this was actually difficult to get, to be able to expose the cutout of the CLT element, that became the element became the finished corner, the finished surface of the insertion of the door. On the inside, you see that we have insulation, 50 centimeters insulation, and a gypsum board. This is due to both acoustic and fire regulations. The fire regulations in CLT buildings are not really that difficult. It's really the sound that is more difficult, I would say. And it's illustrated here, actually. This is a cross-section from the facade. This is CLT elements, and for the longest time we worked without not having a false ceiling. because they didn't really quite know if we would need it or not for student housing. If it would have been regular housing, it would have been kind of regulatory that we would need a false ceiling with this type of construction, which is just a CLT element. But student housing is a little bit more slack in acoustic requirements because it's not permanent housing. So together with a small insulation and a sort of a cast, this could have been enough. But they wanted to be absolutely sure that they wouldn't get complaints from the students, so we built a small false ceiling. You could have solved this in another way. You could have had a CLT element and gravel on top, and then a small kind of a thin floor on top, and then that would in heaviness have given the sort of acoustic capacities that you would need. But then we would never been able to build 9 floors within that height that we were able with a large ladder. Then we would have only been at 8 floors, and then there's this kind of economic balance. Of course, the clients want to build more, and also they were a little bit afraid of putting gravel inside a house. They thought that was sort of like that was a really old school way of building. We can't put the gravel inside a house. But I know this is done probably in Austria and in Germany. It's a standard solution. Yes, so you have the CLT element, then you have a 250 insulation on the outside, and then you have a air gap and a wooden cladding. No, inside you have the same kind of insulation as towards the inside, 50 centimeters plus a gypsum board. There's one wall is always wood in all the units, so that you have gypsum, CLT element, and then you have the exposed CLT element. This is what one could manage within those, let's say, fire regulations. In the kindergarten, the sound requirements are not so strict as when in housing, and it's also a lower building, so you don't have the very strict fire regulations when it comes to escape, but when it's so low. So here we were able to expose the wood from the outer wall elements towards the rooms, and together with built-in furniture in varnished pine plywood, we could create a rather wholesome sort of interior experience of wood. On the outer wall, we did not have to have the insulation plus a gypsum board in the kindergarten. There we could just have this sort of detail where the cutouts for the window is the finished surfaces, actually. Here you see 3 different wood elements, wood products. You have the CLT, you have all the dividing walls that are not load-bearing in the kindergarten are clad with plywood, and then you have a wood fiber ceiling for acoustics. And this is just to show the playfulness that you can do with CLT. You could basically just take a motor, a chainsaw, and cut out. It doesn't become so nice, but you could basically do that. If you would want a new window, you could just cut it out. What is tricky with these large massive wood CLT constructions in Norway is that there isn't any regulations really on how the perfect fire details or the perfect sound details. So everything is a very sort of like a tight work with the consultants, and you can just hope that you get a really good consultant. And we had that. We had a really good fire consultant. And what we did as well was that we did a full-scale fire test of a unit in Trondheim at the laboratory at the university to see how it really behaves when there's a full fire. So it was used to see how the sprinklers work, because this is full sprinkled the whole house. And this is not the sprinkling is not special to a wooden house. In Norway, you have to sprinkle all houses that are that high. So it doesn't give an extra cost because of the massive wood, it's just standard procedure. So if the sprinklers work, which they're supposed to do, they put out the fire immediately. If the sprinklers don't work, then this is what happens. The fire develops quite fast, but in order to control that fire, there's a number of things that we can do. For example, the in-burning time, the massive wood element in the wall is made of different lamellas. So on the wood side, if when it burns into the wooden element, the outermost lamella will protect the inner more structures, whereas from the other side, the gypsum will protect it. If it gets so hot that the window explodes and the fire goes out on the facade is divided into zones, so it can only spread on a small surface. In designing the interiors of the room, it was the quality and the sustainability for the further use for 50 years ahead was again sort of a guideline to us. And the student units are relatively small, so we looked at designing a fixed furniture for the rooms. And this was beneficial for two reasons. It's economic for the student. They don't have to buy a bed. It's a bed and a cupboard and a shelf and a bench and shelf by the window. So you have all that, and you have also a table. You have to bring the chair, but the table you get. Because they don't have to bring any own furniture. Basically, you can just come with a bag of clothes and they can move straight in. And also, throughout the years, it had turned out that if they have their own bed and their own furniture, they tend to leave so much behind when they move out. So it also becomes a lot of work for the student organization to pull these furnitures that students kind of leave behind, and what do they do with them? It's also not a very environmentally sustainable. So it's more environmentally sustainable as well to have fixed furniture. And it's a little bit more sensitive as well to the moving in and out periods, because the student village has a rather high turnover in students. So so if they would bring their benches and beds inside, it would most probably create a lot of damage on the walls, and then they would have to maintain and sort of fix all these dents in the wall. So now they don't have to do that. This is from the student unit. It is very specific to the Trondheim student organization, not necessarily to other student organizations in Norway, but especially to Trondheim, that they really believe in this idea of having students in a collective, that they don't want to provide student housing where you have your own, for one person, your kitchen and a toilet and your own sort of, almost like a mini apartment. They have a sort of attitude that they want to foster tolerance and cooperation, and it's important as well for these young students to learn how to solve problems, small, insignificant problems of who washed the dishes the last time. This is something that they want to train with the students, because it's the students they're not that old when they start studying, and it's their first time away from home as well. And in a city like Trondheim, which is a big technology town, that you have students coming from all over Norway. So it is also a sort of the collective is also sort of an idea, the 15 collective is also the idea that maybe you find someone there. I mean, you don't have to be friends with everybody, but you find someone there that can be a little bit, that you can get to know a little bit better when you're away from home. Typical to wooden structures. This has the characteristics of shrinkage in tangential and radial directions. And this was a challenge from the engineers directly to us. How do you solve the problem when the house is going to shrink from 5 to 8 centimeters in the course of time? How do you make sure that the cladding doesn't get tension? So in order to deal with this problem, we designed a sort of a telescopic facade, which would absorb the shrinkage during time. And we were inspired by two things. We were inspired by the pine cone, with kind of overlapping scales. In the wooden cladding, it always overlaps the underlying end grain, so it doesn't absorb water. And this is also a very traditional detail, which is seen in stave churches, because stave churches are also massive wooden constructions with a wooden cladding on top, which is almost like a big raincoat. And in the same way, the cladding of the towers also work as a raincoat. What kind of wood the facade was going to be in the end was also subject for many discussions and many work meetings. Originally we proposed sort of like a hardwood, but that would maybe need a little bit of maintenance, and maintenance was from the beginning to the end a sort of a leading topic in all the decisions. So we ended up choosing a material which is called kebony. It's actually a Norwegian product. It's a soft wood that is treated with a plant-based liquid that makes it more sustainable for weather. And when it's mounted, it has a slightly sort of a brown shade, but during time you can leave it untreated, and it will weather naturally and get the gray stain. The difference between the kebony and, let's say, a sort of a hardwood which is untreated is that this will age a little bit more evenly than if you have completely untreated hardwood. On the first floor, you see it a little bit here. On the first floors of the facade, it is treated with a fire-resistant coating, because at the same time when we were planning these, there was some crazy guy who was going around in Trondheim and putting buildings on fire. So they wanted us to do something about it. So we found this. It's a sort of a paint that you paint on, and that has to be maintained every 7. So this is maybe the only maintenance thing that has to be maintained on such a short span as approximately 7 years. But it's on a manageable height, because you don't have to have a full scaffolding to do it. You can do it only here. Also in the interior, in the staircase, that's also treated with a transparent fire coating to be able to have exposed wood inside in the staircase. Yes, there you see the towers together with the existing buildings. And one of the thematics that became really really sort of beneficial or unexpected was the solar shading. We hadn't sort of counted that this would make such a big difference, but it did. We proposed that we needed solar shading in all the other facades except the one that's straight north, and these would then go down sort of automatically. But you could also lift them up if you don't want to have the solar shading. So we chose to propose that all the towers have a different color to give it a little bit more playfulness. And surprisingly, this simple idea was very, very liked by the student houses. This was one of the ideas that they took immediately. But there was another set of ideas we have to work a lot with to get through. But this they liked a lot. So the tower A is green, and the tower B is red, and tower C is brown, orange, and then there's tower D is gray, and tower E is blue. And we also used the same color and the color schemes inside the tower and the entrance room to sort of give it a little bit of identity. All in all, this process has been quite fantastic from the beginning to the end, and that is due to the ambition and the dedication from the client and the contractor, Veletrh in Norway, and also all the fantastic consultants that we work with. The engineer was fantastic for the structure. He really knew what he was doing, and he was a specialist in wooden constructions and CLT. And also the fire consultant was really great. And those are basically the main consultants. And also the acoustic consultant was really good. And this collaboration was awarded a couple of days ago, actually, when we were selected to the 40 shortlist in the Mies van der Rohe prize from 355 nominees. This was really great.